Hey guys, it's AJ from Design the Everything. Today I'm answering another viewer request for a tutorial. This viewer asked about using the parameters within Fusion 360 to create intelligent models. So to do that, today we're going to create a 3D printed thrust bearing where we will be able to adjust the size and the number of ball bearing elements within it. When you create models and you add dimensions to those models, you may not realize it, but actually in the bowels of Fusion 360, you're creating what basically looks like a spreadsheet of what each value is called and what its value is, or what each variable is called and what its value is. It's very similar to something like Excel, or if you're familiar with programming, you declare all of your variables, their type, their name, and similar. Just like with programming, you can hard code a variable deep inside the program where it's hard to find. You can declare it as a constant up front so that it's easy to find and change, but won't change within the program. Or you can make it a dynamic variable, one that'll change, one that the program itself can change. Fusion 360 can do all of those things. So going over to Fusion. So let's go ahead and start this off before we make anything with some of the math that goes into it. So we're going to go to Modify and Change Parameters. Now, this will be empty right now because we haven't done anything, but you can see that there's user parameters and model parameters. And then there's the name, the units, and the expression or the equation if you want to equate this to Excel, what the actual calculated value is, and then you can leave comments on it. So I'm going to go ahead and make a user parameter. Let's call this diameter. Let's call this major diameter. Let's do it in inches. And the expression we'll get to. And this is the diameter of bearing. It does need a expression, so I'm just going to fill it in with 5, and we'll fix it later. So I'm going to add a couple more. So again, to add them, I'm just pressing this plus sign. If you want to delete them, you can hit that red X, and you can hit the star button here, which will add it up here to the favorites list. So when you have a bunch that pile up as you're doing sketches and so forth, you can isolate the ones you want with that star. So I'm just going to go ahead and fill in hopefully everything I need. All right, so let's go ahead and start doing some of the math here. So to change the math, or to do some of this math, all you have to do is double click and you can edit. So also notice here that you can reference other reference other parameters inside these parameters. The pocket pitch diameter, this is going to be the major diameter. So it pops up a box down here of a suggested one. You can click on that and it'll autofill it. So this pitch diameter, that's going to be the diameter. Okay, so there's going to be the major diameter, the outside diameter. Then there's going to be a circle of the ball bearings going around. And the diameter of that circle, I'm just calling the pitch diameter. So that's going to be the major diameter minus 2 times the pocket offset. So times pocket offset. Okay. And notice here that this value still doesn't mean anything, but it changed to be correct. So when we fill out all these other values, that will be the correct pitch diameter. I did already measure the ball bearing diameter, and there's actually one more parameter. We need a tolerance in here. So I'm going to go ball bearing tolerance. It's going to be in inches. Let's try 0.05 inches. That'll hopefully let them spin freely. So this is extra space added to pocket to allow free motion. All right, so now we need to figure out how many ball bearings we're going to have in our pitch circle. So we're going to come down here to the number of bearings. So now we need to calculate the circumference of the pitch circle. So 3.14 times the pitch diameter. So pocket pitch diameter. So that's the circumference of the pitch circle. And then we need to divide it by how much space each pocket needs. So that's going to be, so that divided by pocket, so parentheses, pocket spacing plus the ball bearing diameter plus the ball bearing tolerance, close parentheses, and there it autofills. Except this is right now in inches. The number is not going to be in inches. This needs to be unitless. We actually can't go back and edit the unit. I made that mistake earlier, and we need to make a whole nother parameter. So let's try this again. Actually, before I do that, I'm going to change this name. I'm going to just take off a couple letters because you can't have two parameters named the same thing. And so I'm just going to try this again. So number of bearings and change this to no units. Expression I'm still going to put as one comment. I'm just going to put a filler. And now I'm going to copy paste. It automatically tries to put in units in these other expressions because everything I have here doesn't have units. But now that we've made this unit list, we have to delete that or it'll throw an error. And there you go. So now we have the number of bearings. I'm going to delete that. Remember when I said that this is a lot like Excel? You can do a lot of the same functions. So this value here is a decimal, and you can't have a decimal number of bearings. So we're going to go ahead and round this. So I'm just going to type in round and hit enter. And notice that earlier I added parentheses. So now it's going to round that to 7. If we change our value here, say 4, it goes through, does all these calculations, and change that to 4. So we aren't going to have to worry about tenths of bearings or anything dumb like that. All right, so I'm going to make some of these values a little bit more reasonable. So earlier I made another mistake. I should have made this pocket diameter a calculated value. So I'm going to change that to all caps just to tell me it's calculated. And then this should be the ball bearing diameter. Oops, I hit tab trying to autocomplete like it was programming. So ball bearing diameter plus the ball bearing tolerance. Now notice I did that same addition right down here, and I could have just used this pocket diameter, but I forgot. So that's in there. All right, so the pocket spacing, 1 inch seems a little bit much. Let's try 0.25. I'm just filling in reasonable values now. The pocket offset, let's try 0.5. And 4 inches seems fine to me. All right, so I'm pretty sure we have all of the math done for the intelligent elements. Let's go work on the dumb elements now. So I'm just going to hit OK. And the first thing we need is a sketch with our circle. So this will be the main part of our bearing here. So I'm going to click and I'm going to hit D for dimension. And now when I go to fill in the dimension here, I can start typing major diameter, and hit enter. And see that fx means function, and it automatically fills that in. And that's how these functions work. That's how these parameters work. So now if I go back into my parameters, which are under modify here, change parameters, I can make that a 3.5, hit OK, and this circle just became 3.5 inches. So I'm going to hit stop sketch. I'm going to extrude this out 1/2 inch. That is just an arbitrary amount, and hit OK. So now we have our basis circle. So let's go ahead and start creating the little pockets for these bearings to go on. So I'm going to hit sketch again and put it right here on the surface. So now we need a circle that's going to hold our well, first we need our pitch diameter circle. So I'm going to put that there. I'm going to make this a construction element over here. Hit D for dimension, click on that, and this is going to be the pitch diameter, or the pocket pitch diameter. There we go. So that's going to be the center point of all of our bearings going around. On the center point of each of the pockets will be on this circle. So I'm going to do another circle, and this is actually going to be our pocket. And I'm going to put that on here. And then I'm going to do one more thing where I'm going to put a vertical line in here. I'm going to make this line a construction element, and I'm going to constrain it to be vertical. So vertical, okay, actually that little symbol right there means it's already in. So I shouldn't be able to move that at all. And then I'm going to coincident, again over here, coincident the center point of my circle to this. You want to use these geometry constraints a lot more when you're working with all these parameters, because if you hard code in a number, when you change the formula parameters, it'll break things. So you want to use the geometry parameters. But I'm going to go ahead and put in, I'm going to hit D for dimension, click on my circle here, and this was pocket diameter. Yeah, pocket diameter, which is calculated, and hit enter. Now that we have that, we can go ahead and hit stop sketch. And now I'm going to extrude that down. And this I'm going to do with a dumb value. Actually, better yet, I'm going to use a formula inside this bar here. You can do that too. So I'm going to do this with the ball bearing diameter divided by 2. So you can do a formula right there in that bar. Half of my little ball bearing will be sticking out of this hole, and the other half will be in it still. So let's go ahead and make the rest of these going around. So I'm going to come over here and create, I want a pattern that is circular. I don't want, so down here at the pattern type, you don't want faces or bodies, you want features. And when you choose the feature, the easiest way to do it is to come down here to the bar and just click on that extrude there. For the axis, I want the center axis of my circle. All right, so the quantity, now we can type in the number of bearings parameter, and it automatically does that for us there. So let's hit OK. And there is our, well, at least the first half of our thrust bearing. Let's go ahead and play with the parameters and see what happens. So let's go back up here to change parameters. Let's make this bigger. Let's make it 5 inches, so much bigger. So you can tell now it's added more bearings all the way around. It's kept this offset the same, and the spacing's the same. Isn't that cool? This will come in really handy if you're having to design the same thing over, or a very similar thing over and over again. For example, let's say you're designing shoes. You could just have it all based off of one shoe size and everything just multiplied down. So all you have to do is, let's say you type in size 7, save the STL so you can 3D print it, change it to a size 8, save the STL so you can 3D print it, and so forth. So now notice, going back here, there's our user parameters and this little drop-down box that says model parameters. If we click on that, it'll have the name of your model, which I still haven't saved. I should probably do that. And then all of the different elements you've made, so a circular pattern, for example, and it'll show you the name that it has assigned to it, which is always D, which means dimension, and then a number sequentially, and the value over here. So it does actually a pretty good job of describing what it is. So our count, it's calling D17, but we assign that to be the number of bearings, which is 19. Where's our extrude here? So this is our extrude, which we just hard coded, and that's 1/2 inch. And you can actually go back and change these names here. You can go back and call that major thickness, and hit OK. So let's go ahead and make the other half of this bearing. All right, so let's go ahead and put the hole in the middle, sketch, put it on top. I'm going to do a circle. And when I hit D for dimension, let's call this 1/10 of the major value. So I'm going to set 0.1 times the major diameter, and hit stop sketch. So let's go ahead and extrude that 2 times the major thickness. Now notice, since this is a parameter I renamed, and I don't know why, it's just a fluke of Fusion 360, it does not auto-complete it for you. In fact, it'll put it in red for a little while before it realizes it's right. So let's do that times 2. Yeah, sure, times 2. 2 times the major thickness. Some of the more advanced CAD packages like Autodesk Inventor, which is what I use for my day-to-day production work, you can link 2 different documents parameters. So that if I wanted to go do the top of this, I could do it in a different file, but use all the same parameters and just move them over. And when I changed one, it would change in the other. Fusion 360 doesn't have that capability. But what we can do is build the top just right next to it. So I'm going to go ahead and create a sketch, do it on my base plane again, come out to the side, and I'm going to create a circle. And basically just go through this whole process again. I'm going to go ahead and print these out, and I'll show you the final results. Hopefully it works. And if it doesn't, we can just change the parameters. So after 3 hours of printing, my little bearing is done. I did make one mistake on the drawing. I don't know why I decided to make that double the thickness when it only needs 1 thickness, so that's a little bit silly. But other than that, it works surprisingly well. It turns well. The bearings probably could also be in a little bit deeper hole, but this will cut out on some drag. That's what that looks like. And we can make these any size we want, or at least up to the size of my printer. So now, obviously, it won't last as long as a professional one with, hardened steel on all different pieces of it and whatever, but it's a 3D printed one and it works. Thank you for watching. I really hope you enjoyed this video. I had a lot of fun with this one. If you liked the video, please hit the like button. And if you want to see the rest of my videos as they come out, please subscribe. Thank you for watching.